So we've been talking about reliability since the start of this class, and I really want to focus on reliability, how we actually analyze reliability, and how we look at reliability in various tests. And generally speaking, we're expecting to find a reliability because, again, we have that underlying assumption that we're measuring relatively stable constructs. So again, reliability isn't necessarily validity, and validity isn't necessarily reliability. And this is just a quick visual representation that basically, when we're talking about reliability, we're talking about consistent measurement. So both the right and left images are examples of reliability. However, if what we're trying to do is actually measure a construct and make sure that all of the items that are measuring that construct are not only reliable, but are also truthful measure of that construct, we're really just looking at the right image there, where basically it's both reliable and valid. So for example, the bottom ones are basically low validity, or the middle ones are low validity and low reliability, not reliable and not valid. However, we do have an example of a reliable but not a valid. For example, if we were using a measure of height in feet and inches, it would probably be fairly reliable, especially if you're an adult. So we generally stayed at the same height, approximately between the ages of 18 to 20, all the way up to basically our late 70s is when usually we start to see a little bit of decrease in height. So we'd expect a lot of reliability. However, if I measured your height and insisted that was a measure of your cognitive ability, I would have a reliable but not valid test. So one of the ways we look at reliability, obviously, is statistically with correlation and regression. So we'll be reviewing that. We'll talk about some of the causes of unreliability that we can actually design our surveys, our tests, our assessments around to ensure that there is less chance that there is unreliability. And finally, we're going to talk about how we actually measure reliability in various tests and assessments. So again, reliability is consistency in measurement, and the reliability coefficient is an index of reliability, a proportion that indicates the ratio between the true score variance on the test and total variance. So again, true score basically is never going to necessarily equal observation, because observation is always going to have some error in it. However, when we're looking at reliability, it's one of the two ways that we're trying to determine how much error is there. There can be error in validity. It's not a good measure. It's not a truthful measure. There can also be error in reliability. So again, I kind of talked about that when we're talking about this idea of a true score is the equivalent of observation plus or minus error, but some of that error is going to be brought by the test taker. If the test is actually being delivered by a test developer or a test assessor, there may be some error there too. But there can also be error inherent in the test itself, and that's what we want to focus on to minimize. So error refers to the component of the observed score that does not have to do with the test taker's true ability or the trait being measured. And measurement error is all those factors associated with the process of measuring some variable other than the measure itself that's being measured. In other words, it's error. So error in broad terms is basically anything that we're capturing that isn't the actual true score. And the true score is never truly knowable. We infer the true score from our observation with hopefully a small amount of error. And when we talk about measurement error, we're specifically not talking about all of the error. We're not talking about individual differences. We're talking about factors that might be under our control, other than the variable being measured that's being captured by our test or assessment. So again, true score equals observation plus or minus error. So reliability is the consistency or dependability of a measure over time, scores, and specific content. Do scores change if a test is given on several occasions? And again, there's an assumption here. If we're expecting there to be differences, we wouldn't expect reliability. So for example, if I didn't expect you to have any prior knowledge of, for example, horse veterinary care, and then you took a 3-week class on learning how to take care of first aid in horses. And at the end, I gave you a test, again, that same test of horse veterinary knowledge. I'd expect you to do better. So there's a lot of times when reliability is going to be more of a question of not necessarily how reliable is the test from time 1 to time 2, but how reliable is it catching. In other words, when I give that test at the end of the 3-week class, do I find the students that were most attentive, had hands-on shown the most skills in the techniques being taught? Are they also the ones that score highest? In other words, we're going to often compare that final test to other measures of performance. But in a lot of cases, we're measuring a construct. We're measuring a psychological concept, for example, extroversion, and we'd expect that to stay relatively stable. And in that case, we're going to be looking at reliability simply as a measure of test and retest. If I give you a test of extroversion and 6 weeks later I give you the same test, I'd expect you to score fairly similarly. So, for example, do results of this questionnaire depend on the rater themselves? That's another thing we can think about. So, consider that there are a lot of times out there where we're actually not actually providing scores ourselves, we're being scored. We see this a lot in sports, boxing, figure skating, where there is a set of judges who give a score based on their performance. So, the other thing we can look at reliability is, again, if it's a reliable system, a reliable set of rules for the scores to be assigned, we'd expect people to strongly agree. So if everyone's looking at the same thing in a boxing match, for instance, we'd expect those boxing scores to maybe not be perfectly the same, but we'd expect a very similar amount of scoring across three different judges. And if there isn't, we'd say they're less reliable. And if you're a fan of any particular sport that involves scoring, you probably know the frustration when one judge or multiple judges are wildly different from each other. It's hard not to wonder if one of them's basically been paid off at that point. It may also be they were looking at something very differently. I'm a pretty big fan of boxing, so I'm very used to watching boxing results where I am surprised by at least one of the judges. But then I also remind myself that I'm watching for basically how much I think the person's dominating the match, how many times they've got a punch through that actually hit and did damage. They may simply be just keeping track of who's moving forward versus who's moving back. There may be different things they're looking for. Now, if all three judges were basically using the same set of rules, we'd expect it to be more reliable. So there's another way that we can look at reliability, and we'll talk about one of the measures we use to look at basically inter-rater reliability. And finally, we might use reliability to determine if we can use alternate forms and still give the same results. So if you've ever been in a class where you've been given a test and some of the tests are pink and some of the tests are green, or some say form A and some say form B. In those cases, each test may have 50 items, but it may be 50 slightly different items. Now, hopefully they've actually been matched for difficulty and what they're actually measuring. But one of the ways we can look at is that if I do have alternate forms, I would expect that the average score on each of those forms should be approximately the same. In other words, if I have a Form A and a Form B that's meant to basically measure your performance in the first 4 weeks of this class, I give it to 50 students, 25 get Form A, 25 get Form B, I would expect there to be a strong correlation between those two forms, that they measure the same thing approximately, they get the same score. If I found that on Form A, people scored on average 90, and if on Form B, people scored on average of 70, it might be that I got different people in those groups, but if it was truly randomly assigned, that's probably an indication that one of those forms is not the equivalent of the other. So really what I want you to think about is when we're looking at reliability, we're looking at reliability across three big questions. We're looking at reliability as a way to look to see if a measure or a test or an assessment of a stable trait basically gives us the same results when given to the same person. That's the first form of reliability we'll look at. The second form of reliability we may look at is trying to quantify how successful raters are being at giving very similar scores. And I use sports there as an example, but also a lot of times when people are interviewing, it might be a panel interview where 5 or 4 or 3 people at the end of the interview all rate the interviewer on a scale. We'd again expect if they're reliable and they understand what they're rating and they're looking for the same things in that interview, that we'd see very similar scores. Again, if it's a 1 to 5 score, we wouldn't expect everyone to be a 4, but we definitely expect them to be around a 4, maybe a 3, a 4, and a 5, maybe a 3.5, a 4, and a 4.5. What we wouldn't expect is a 1, a 3, and a 5. That would be unreliability in our raters. And finally, we might also be looking at reliability as a way to determine if we can have multiple forms that are measuring the same thing. So let's move on to causes of unreliability. So test scores, different judgments are provided by different raters, and interreliability in testing can be used basically looking at what we're actually looking at as far as how to measure this. And how we measure testing scores, so people scoring, judges, if you will, is usually going to be used the kappa for categorical data, because it really is going to be generally some form of categorical data. how you scored the match. Generalizable coefficients for continuous data is the other technique we'll use. So if it's categorical data, pass or fail, we're going to use kappa. If it's a range, 0 to 10, we're going to look for coefficients or correlations. So for example, if we're looking at just simply a correlation between two continuous data, we'll simply look at rater 1 versus rater 2, or rater A versus rater B. If they're both rating things on a 0 to 15 scale, each dot represents how they rated one person. So for example, the first person there at the bottom was rated 0 by both raters. That would be perfect correlation. And likewise, the top one was rated a 12 by both. That is, again, a good correlation. That means they both said the same, but they didn't always say the same. So for example, the next person over, we see a dot at 3 and 3. There we go. But then we see one at 6 and 5. We see one at 9 and 6. We see one at 6 and 9. We see some variance. Now again, broadly speaking, they're in the range. They're agreeing. They're just not agreeing perfectly. And we want to quantify that, because if there is an imperfect correlation between raters, that means that there is some unreliability, there's some error that we can measure, if you will, in the actual assessment. So ways we can look for causes of unreliability. Basically, with test construction, variations may exist within items through the test between tests. Item sampling and content sampling are things we can look at. We can also look at test administration. So basically, within the test content, we may be looking at a larger portion. For example, if I'm creating a test that's supposed to be measuring the last 4 weeks of a class, but most of the items are coming from week 1 and 2, well, if you attended week 1 and 2 and really paid attention, you're probably going to do really well. But the people that attended week 3 and 4 and paid attention are not getting rewarded. So that might be an example of unreliability. Someone who attended the first 2 weeks and skipped the second 2 weeks could still do really well. But someone who skipped the first 2 weeks and attended the weeks 3 and 4 actually would do very poorly. And someone that actually attended all 4 weeks might find that they had spent some time studying items that weren't really even on the test. So again, that's one of the ways we can look at causes of unreliability. And that's an example of a test. But if we're looking at an assessment, if we actually have, for example, a measure of extroversion, we want to think about all of the different things that make up extroversion and make sure that there's an equal proportion of items around each one of those if we're truly trying to say that that's the construct we're measuring. It can also just be as simple as having an incorrect answer key. So having an item that's miskeyed, which means that someone is basically being told they missed it when they didn't. That would also be a source of error. So test administration includes unreliability of procedures. If some people are given an hour and a half to take the test and some people are given 55 minutes, that would be an example of test administration. If some people take the test in a very quiet environment and other people take it in a noisy office, that would be unreliability of tested procedures. In other words, we would probably capture at least some of that in the assessment, and that's not the observed score. That's not what we're wanting. That's not the true score that we're after. That's observed score plus error. Personal conditions, so again, random error during the testing. Now, some of this is out of our control, but we can also make sure. Think about whenever you go into a doctor's office and they take your blood pressure. They'll usually ask you to take 3 deep breaths and kind of just relax for a few seconds. And the last time I was in, they asked me to relax for 15 seconds before they took my blood pressure. That's basically trying to make sure that everyone is at a similar base rate before they take the actual blood pressure. They're trying to reduce error. And finally, the measure itself may be unreliable. Questions may not be clear, they may be hard to understand, there may be cultural differences, the questions may not be consistent. Also, sometimes we're just trying to measure something that the construct itself is not clear or reliable. A lot of new measures are trying to measure things that may not be well defined. And that's one of the things that we're also going to talk about, is that when we're creating a new measure, one of the things that we're going to start with is actually an operational definition of the construct we're trying to measure, which is going to help us guide the items we're going to ask. So sometimes we might want to go back to that operational definition to see if it actually is accurate and a good construct that we can measure. So measures of reliability. Probably one of the most common is the test retest. So once we have a measure, we give it to a group of people. The same test is given to the same group of participants at 2 different times. Participants should get approximately the same score each time. And again, we wouldn't expect it to be perfect because there's still going to be some error, but we'd expect there to be a strong correlation in this case. Reliability is measured by correlating the scores from the first and second measure, and each dot representing one person taking the score. And again, you can see at time 1, Someone scored a 10 and a 10, but someone else scored a 10 and an 8. So there was some error. So, and again, it's not a perfect line, but it would indicate a relatively reliable test based on this measure. So in this case, it's a self-reported depression. Reliability is measured by correlating the scores, the first and second measure, and we can then talk a little bit about some of the things we might run into. The first one is, generally speaking, the potential problem can be testing effects. In other words, the person is familiar with the test. They may actually take the test more seriously the first time. They may take it less seriously the second time. If it's an educational test, they probably have learned a little bit from the time 1 to time 2, and they also are more familiar with the test. Think about the very first time you ever take a test. There's probably some anxiety. What's going to be on the test? What questions are going to be asked? How are they going to be asked? Especially if it's a brand new class. When you take the second test from the same professor in the same class, it's new items, but you now have a better idea of what type of items that professor asks and what type of questions you can expect. So you're probably going to do a little bit better the second time. And that's one of the things we often find with test retest, especially with educational achievement tests. We find that correlation, but people do tend to score a little bit better on the second time. Generally speaking, what we'll often refer to this as the coefficient of stability, and that's usually going to be looking at over 6 months. Probably, honestly, for most assessments that we're looking at personality, one of the ways to get around the testing effect is to wait approximately 6 weeks between testing. You can wait as long as 6 months, but generally speaking, you want to wait a minimum of 6 weeks before you retest if you're looking at the coefficient of stability. And a lot of times when we actually report a coefficient of stability, we're specifically talking about time 1 and time 2 having 6 months between them and looking for that relationship. If we're looking at alternate forms, we're still going to use the coefficient. We're still going to do a correlation, but now we're looking at similar versions of the test that are given to the same participant. Reliability is measured by correlating the scores from each form. So we give form A and form B, and we look to see that relationship. And on the left, we have an example of a fairly strong relationship. This would be an example that basically people that performed well on form 1 performed well on form B, and there's a strong relationship there. We'd be fairly confident in using these two forms. But if we look at the correlation shown on the right, we probably would be less confident. There's some people scored well on Form A and scored poorly on Form B. Some people performed great on Form B, but performed poorly on Form A. So again, we kind of want to think about what these are telling us when we're looking at the data. It's not just getting a value. We can definitely do that and basically determine a high score means that we have reliability. But it's also interpreting what happens when we don't have that high score. What's going on here? In this case, looking at the right, I would probably want to look at Form A and Form B more closely. I'd probably want to categorize it into hard, medium, and easy answers. And I'd probably also want to categorize the questions into subject areas and to see, are the two forms truly similar? In other words, are there 10 items from, if it's a history test, are there 10 items from Roman history, the first 100 years, on both tests? Is there 10 questions on the emperors of Rome? Are there 10 questions about the fall of Rome? If I saw that there were similar questions, then that's probably not what's causing this problem. I would probably then look at difficulty. So I'd look at the difficulty of each item. How many people are getting them right? So within each of those subgroups, do I see a similar spread of difficulty? Those are probably going to identify why I've got a problem, and I can probably make some adjustments to get closer to what we see on the right, where Form A and Form B are performing very similarly. So again, the one on the right is an example of good reliability. We could probably use those two separate forms to measure the same construct. The form on the right is bad reliability. We would probably not want to use those two forms and assume that we're measuring the same construct. So finally, we talked about inter-rater reliability. So inter-rater reliability is basically when we're looking to see if raters are in agreement. And one of the ways we can look at this is if we have 3 raters and they're rating on a numerical scale, we can just start looking at their scores across multiple individuals. So for example, if we have 3 people rating people on a 1 to 10 scale and they rated 15 people, we could correlate the 3 raters' scores on those 15 people to see is there a strong relationship. If it's a pass-fail, or if it's basically a categorical or dichotomous decision, we're going to use what's known as Cohen's kappa. It measures the consistency of raters given that the same participants have different raters. And basically, the equation for Cohen's kappa is we get the percentage of times that the people agreed minus the percentage of chance divided by 1 minus the percentage of chance. So generally speaking, what we're looking for here is 0.75 to 1.0. That's generally considered excellent agreement on the Cohen's kappa. 0.75 to 0.4 is good agreement, and below 0.4 is questionable. So we're going to go through some examples of how we actually calculate this in the next slide. So again, we're looking at percentages. So if we had two different raters in this case, Dr. Seuss and Dr. Dolittle, and they're rating people categorically. They're rating people on whether they have ADD, ADHD, or neither. So the first thing we're going to look at is how many times did both raters say that someone had ADD? That was 15%. So 15% of their ratings actually agreed that this person had ADD. However, with Dr. Dolittle, so we're looking across the row, 5% of the time when he said ADD, Dr. Seuss said ADHD. And again, 5% of the time that he said ADD, Dr. Seuss said there was neither. So those are examples of disagreement. Again, if we look at ADHD, Dr. Dolittle and Dr. Seuss agreed 20% of the time. And 5% of the time when Dr. Dolittle said ADD, Dr. Seuss disagreed and said ADHD. And likewise, again, when both of them agreed with neither, it was 40% of the time. Now notice that each of these ends up to be 100%, but the actual percentages in the middle are the agreement. So if we look at Dr. Dolittle, 25% of the patients he said had ADD. 25% he said had ADHD, and 50% he said neither. If we look at Dr. Seuss, these are the yellow blocks, 25% of the time he said ADD, 30% of the time he said ADHD, and 45% of the time he said neither. So both of these are across 100 people just to make it easy, but these are the percentages. So the first thing we do is we'd simply add up the number of times they agree. So 0.15, 0.2, 0.40, the pink boxes. That becomes 0.75. Then we look at the number of the basically P chance. And P chance is multiplying the percentage of how many times they gave either rating. So it's basically the green box for Dr. Dolittle for ADD and the yellow box for Dr. Seuss ADD. So 0.25 times 0.25 plus ADHD for both of them, 0.25 times 0.30 plus neither for both of them, 0.45 times 0.5. So we multiply each of those together and then we add up the results and it becomes 0.3625. Once we have these numbers, we simply add them into the equation. So again, we're calculating Cohen's kappa. Our agreement was 7.75. We minus that from their P chance, which is 0.3625. And then we divide that by 1 minus chance, 3.625. That gives us 0.38675 divided by 0.6375, which equals a Cohen's kappa of 0.60. And if you remember from the last slide, this is moderate agreement. In other words, it's not great. There are definitely some disagreement going on here. But you can just look at it to see that when we're looking at the actual chart, they agree on most of the diagnoses. In fact, when we look at disagreement, it's usually 5%. 5% across the board. And one time they actually didn't disagree at all. And that was on Dr. Dolittle's ADHD and Dr. Seuss going neither. He didn't choose any of those. So again, this is a way that we can actually create, without a correlation, we can just basically hand calculate if it's categorical data. And obviously this can become easier if it's simply a pass-fail score. So that's how we actually calculate Cohen's kappa. There are computer programs that do this, but honestly, this is one that you can easily do yourself. All you need to do is actually decide what the percentage of agreements are between your raters, and then simply plug the numbers into the actual equation. So we're going to pick up on this with the next lecture and start talking about other ways that we can look at reliability.